Oh, yeah. Oh, yeah, you should have just bought it. Yeah. Yeah. All right. Sorry about your book close, but we're going to do some math either way. Well, I said we were. There we are. Okay, yeah, we are. All right, multiplying polynomials is what we're going to be dealing with. So we'll start with the easiest of easy, and that's distributive property. Okay? 3x times 4x plus 3. So we're multiplying a monomial 3x times a binomial because it has two terms, 4x plus 3. It's distributive property. That's going to be everything we do when we're multiplying polynomials is distributive property. And that just means everybody gets multiplied by the 3x. So it's 3x times 4x. 3 times 4 is 12. What's x times x? X squared. Okay? Yeah, because you have exponents on those. 1 and you add the exponents. 1 plus 1 is the 2. That's where that's coming from. And then we're going to say 3x times the plus 3. 3 times positive 3 be positive 9, and it has an x on it. And you're done. You've multiplied a polynomial. Okay? Only would stay that easy. Negative 5x squared times negative 2x minus 8. Still distributive property. It's still polynomials. Okay? Multiplying negative 5x squared times negative 2x. Negative 5 times negative 2. Good job. And then the next piece. Plus or minus? There you go. Good job. You can distributive property. You can do multiplying polynomials. Okay. Now here we're just distributing one thing. When we get to this next problem, we're distributing x plus 3 to x plus 4. We're distributing two things. First, distribute the x. X times x. And then distribute x to 4. Be 4x. Then distribute the 3. 3 times x. 3x. Then 3 times 4. Okay. Now you look to see if you can combine any like terms. We didn't have to look for that before because we didn't have much going on. Here we've got some like terms in the middle there. We got a 4x and a 3x. They go together because they're both plain x's. So together that would be x squared plus 7x plus 12. And there is the multiplied version of that. Okay, so it's just distributive property more than once. That's all we're doing. Example D. X minus 7 times 2x plus 5. Okay, so we're distributing the x. That'd be 2x to the second plus 5x. And then negative 7 times 2x. Good job. Combining like terms. 5x and the 14x. So 5x minus 14x would be. Good job. And there is the finished product. Those two polynomials. Distributive property over and over. That's what multiplying polynomials is. If you can do distributive property, you can multiply the largest polynomials times each other. Okay? You just got to be careful about like terms at the end. 2x plus 7 times 2x minus 7. Got to watch our signs as we're doing this. Okay. Okay. I don't know why I wrote x squared. It's 14x. That's right. Good job. Like terms. Yeah, 4x. Yeah, these cancel each other out because a negative 14 and a positive 14 makes it empty, kind of like my checking account. And got paid Friday. It's Monday. It's all gone. So. All right. Let's do 2x minus 3 times x squared plus 7x minus 9. How many things am I multiplying 2x to? 3 things. Okay, so it's a little longer, not any more difficult though, right? So 2x times x squared, 2x cubed to the third. Yeah, gotta add that exponent. Gotta be careful of that. That's where mistakes can happen, is those exponent additions and the signs. So then 2x times 7x plus 14x squared 2x times negative 9. Okay. And now, here's a little trick that I do. It's not necessary, but it helps, I think. When I distribute this negative 3, I'm going to stack up the stuff that matches up. Okay? So negative 3 times x squared is negative 3x squared. So I'm going to put that underneath the 14x squared. Stack it up like that so that your like terms are together. And it keeps you from having to have a problem that's 8 foot long to add together. So stacking it up with your terms can be helpful. Negative 21x positive 27. Put those together. 2x cubed just comes down because there's nothing like it. 14x squared combines with negative 3x squared to make plus 11x squared. Negative 18 and negative 21 come together to make. And then the 27 comes down because there's nothing else like it. Bam. Multiply a binomial times a trinomial in that case. 2 terms times 3 terms. That's a binomial times a trinomial. Not that that matters as to what it's called. It's just helping you learn some terms there. Okay? Not hard. Pretty easy. X plus 5 squared. X plus 5 squared. What's it mean to square something? Times itself. So this is really x plus 5 times x plus 5. It's not x squared plus 25. Just go ahead and tell you that. If you've already worked it and you got that, you're wrong. Okay? Because x plus 5 squared means x plus 5 times x plus 5. You're just doing that distributive property the same way. X times x is x squared. X times 5 is 5x. There's another 5x. And there's the 25. There is an x squared. There is a 25, but there's a middle piece that we got to have as well. Okay? That middle piece is the 10x. X squared plus 10x plus 25. It's 2x minus 3 squared. So we got 2x minus 3 times 2x minus 3. So just multiply it times itself. Do the distributive properties. It'll be 4x squared minus 6x minus 6x plus 9. And I did my little stacking trick there because I was running out of room. So works the same though. Putting those together, 4x squared minus 12x. Okay. Distributive property. That's the only thing you've got to know for this is distributive property. And then combining like terms. X plus 3 times x minus 3. Again, distributive property. X squared minus 3x plus 3x minus 9. What happens to the 3x's in the middle? They cancel each other out and got x squared minus 9. That one shortened up real nice. Five x plus 9, 5x minus 9. That'd be 25x squared minus 45x. There's a plus 45x minus 81. 5x squared. What happens to the 45x's? They cancel out. Well, what do we notice with our final answer and our what these are called factors up here? What are we noticing? What's happening to the middle term every time something else happens up here? If the signs are different and the numbers are all the same up here, then the middle term cancels out. That's what's going to happen to everything. What this is called is a difference of squares. Because the reason it's called a difference of squares is because what's 25? It's 5 squared, right? What's 81? It's 9 squared. Look up here. 5, 5, 9, 9. That's going to come into play when we start factoring. We're just taking something that starts like this and going backwards and getting what we started with.
It only works when there's a positive and a
But yeah, for a difference of squares, yeah. Got to have a positive, got a difference of squares. And we'll talk about that more as we do factoring. You just kind of try to mention that as we go along to help. All right, let's look at maybe the longest one. It's not the hardest one, but it's maybe the longer ones for this section. And we'll just do one of them because you can do this one, you can do them all. X plus 3 to the third power. Or better yet, let's make that x plus 2 to the third power. That way we don't confuse the threes. What's it mean to raise something to the third power? Multiply it by itself 3 times. So x plus 2 times x plus 2 times x plus 2, like that. Okay. Now, with this, You don't want to try to distribute one of them to both of the others at the same time. You're better off just taking two of them at a time and multiply them together. So this is what I would do. I would take these two and do that part first. So I would take the ones that I'm putting in the brackets there, and I'd multiply those two together first. So that'd be x times x plus 2x plus 2x plus 4. Simplify that. I get x squared plus 4x plus 4. This x plus 2 from the beginning comes down with that. Okay. So I haven't used it yet. Then I'm just doing distributive property again with the x plus 2 to this trinomial now. So x times x squared would be x to the third. X times 4x would be plus 4x squared plus 4x. And then I would distribute the 2. That would be 2x squared, 8x plus 8. And again, I stacked it up. X cubed, 6x squared, plus 12x plus 8. There is not really a shortcut to that. Don't look for one. There's not one. Get there any faster.
But it doesn't matter which ones you pair.
No, it doesn't matter which ones you pair. I usually pick the ones to the right and then work my way back just because it looks more like what we've been doing. It's not, but it does not. No, it does not matter which ones you do that with. Where it could matter would be a problem maybe like this. Maybe you had x plus 3, x plus 5, and x minus 3. Final answer wise, it's not going to matter which order you go in. But as far as ease of doing it, it could be better to reorder this. What I would do is I would reorder it. Yeah, why would I do that? That middle term's going to cancel out. It's going to be a shorter problem when I get that done. That's the reason that I would do that. So if I do these two, that's going to be x squared minus 3x plus 3x minus 9. I know that simplifies to be x squared minus 9. And then all I've got to do is multiply that by x plus 5. That is a shorter problem than if I had multiplied x plus 5 times x minus 3. I will get the same final answer, but I'll have more steps in what I'm doing or more multiplications to do. So I would do x times x squared would be x cubed minus 9x plus 5x squared minus 45. The only thing that you need to do is reorder that in descending order. So start with your highest exponent and work your way down. So x cubed plus 5x squared minus 9x minus 45. That's the way, the official answer. This is it's called descending order because you're starting with your highest exponent and going down. Doesn't change anything about the problem, just makes it look a little better. Again, the order that you multiply things in does not matter, but sometimes there are advantages to reordering it and doing it in a certain order. It can make the problem a little shorter sometimes. So that's moving in the direction of multiplying. What we're going to do next is moving the direction of factoring polynomials, which is unmultiplying them, okay? So we're going to talk about how to factor and what are the rules of factoring for this next section. So you may have done this in Algebra 1 before, or Algebra 2, or somewhere along the way of your mathematical journey through high school or general education. You factored polynomials in some way. You may not remember it, and that's okay. It's not rocket science. It's numbers, okay? And the better you know your multiplication tables, the better you are at factoring. A lot of times I'll have students that may struggle with algebra, but they're real good at factoring because they know their multiplication tables. Just because they had to memorize them in 5th grade or something like that. They had a teacher that really stood on them and made them memorize them, and they've got them memorized. They're just not real good at algebra, but they're good at multiplication tables, and that's one of the things that can make you better at factoring. So if you're not good at multiplication tables, get the app on your phone, one of those free flashcard apps. There's a ton of them out there. Just when you're sitting there waiting on your next class, just run through them. It takes like 20 seconds to do a round or less, and just work on learning your multiplication tables if you don't know those. It's going to help you not only with factoring, but everything else in a math class. It just gets your brain better number sense. Okay, so here are Isbell's rules of factoring. You won't find these in a book listed out as the rules of factoring. I call them this because I teach it this way for my Algebra 1 students that are in 9th grade. When I have those same students again, when they're in 11th grade taking Algebra 2, I write this on the board and they are like, oh, I remember you doing this in class. So I call it this, and I've called it this for years. It's the rules of factoring. These are the things that work. If you can do these things, these are the things that work and will help you in not learning factoring the way that I learned it when I was in school. I learned it by guessing and see if that's right. And if it's not, try something else. This is a more systematic approach to it, so that if you've got good number sense, i.e., you know your multiplication tables, things can work out faster for you. Okay, so that's why I call this the rules of factoring. The first rule is you want your polynomial that you're trying to factor in descending order. And we talked about that with the last problem in the previous section, where you had to rewrite it in the right order. That would be something where you'd have something like 3x cubed plus 5x squared plus 9x plus 15. That's descending order. Starts with the highest exponent on the variable and goes down. That's descending order. You got to make sure it's in that order first. That makes things work easier. Not that it's impossible in a different order, but it is much more difficult in a different order. Okay. Second thing you want to do is look for a greatest common factor. And we'll abbreviate that GCF. So if you hear me say GCF, I'm talking about greatest common factor. That's a number that goes into every term, or a letter that every term shares. Okay, so everything, if the GCF is 2, then everything's got to be divisible by 2. If everything is not divisible by 2, then that's not the greatest common factor. It's okay if there's not a GCF. Okay, if a letter is part of the greatest common factor, then that means every piece in that polynomial has that letter. And you always can only take the smallest number of those letters. So if you had something like this problem, if I had, change it up a little bit, 4th power, 3rd power, 2nd power, and then an x. That problem right there, everybody has an x. This one has 1 x. This one has 2 of them. This one has 3 of them. This one has 4. The most that they have in common is 1. It's what can each of them give up? Okay, this guy can only give up 1, so we can't ask anybody else to give up more than that. Right? That's fair. That's mathematically fair for us. So that's what GCF, how that works. Okay, so we're going to look for that before we do anything else. We'll put it in descending order. We're going to look for a greatest common factor. Do that first. Okay. The next thing we do after we've done the greatest common factor is we count the terms. The number of terms that the polynomial has tells us what method to use to factor it. Okay? If it has 4 terms, we're going to use this method called grouping. And I'll show you how to do that in just a little bit. If it's got 3 terms, we're going to use a method called the X method. Okay? 4 terms, grouping. 3 terms, X method. Okay? 2 terms. This is where that preview I gave you comes from. It's either going to be a difference of squares, or it could be a sum or difference of cubes. And I'll teach you how to do each one of these things, okay, when we get there. But the number of terms that it has tells us which methods are even possible. So if it's got 4 terms, then we know we can't do difference of squares with it. If it's got 4 terms, we can't do X method. It's got to be done by grouping. If it's got 3 terms, then we're doing X method. We're not doing differences of squares or sums of cubes or anything like that, okay? All right, so we're going to start out with small steps, build our way up to doing some of the harder ones, okay? Instructions are factor the polynomial. Example A, 5x plus 10. Starting with baby steps. Build our way up. This is definitely the longest section of the night. Okay, so we can make it through this one. The next 2 are not nearly as long. All right. Is it in descending order? Yeah, we got 5x to the first power and then a plain 10. So that's in the right order. The next thing we want to look for is the greatest common factor. So we need a number or letter that everybody has in common. 5 goes into itself. 5 also goes into 10. So our greatest common factor is 5. So what we're going to do is take that greatest common factor and put it out in the front of a set of parentheses. What times that 5 that I put out in front gives me 5x? 1 and an x, right? 5 times x is 5x, right? What times 5 will give me a plus 10? A positive 2. A plus 2 will give me, if I distribute that back out, a plus 10. I have factored out the GCF of that problem. Okay? For this one, that's all that we could do. X plus 2 doesn't go any further than that. Okay? 2 is not a square number. X is not even squared anymore. Okay? So that is the factored form for example A. All we could do was a greatest common factor. Sometimes that's all you can do. Greatest common factor is the drive shaft for all of the other factoring. Okay, if we can't do GCF, we're gonna have trouble with the rest of it. Okay, so we're going to first several examples. We're going to be dealing with GCF mainly. Look at this one: 6x squared plus 8x. So we follow the rules of factoring. First thing we look at is it in the right order? Got x squared first, and then plain x. That's descending order, so it's in the right order. And then we look for a greatest common factor between 6x squared and 8x. 2 goes into both of the numbers. How many x's do they have in common? 1. So the GCF is going to be 2x. Because this guy has 1x, this guy has 2 x's. This guy can give up 1. We can only ask the first one to give up 1. So that's why there's only 1x out here in front. Okay? What times 2x would give me 6x squared? 3. And I need how many x's? I need 1x. Because I add them together. Okay? So if it had 2 to begin with and I took 1 out, there's only 1 left. Okay? What times 2x would get me plus 8x? Plus 4. We factored out the GCF. All right. Not bad, not bad. 10 x to the third minus 15 x squared. Is it in the right order?
Yes.
Okay. GCF. 5 goes into 10, 5 goes into 15. Biggest number. How many x's do they have in common? 2. The smallest one has x squared. The other one has x cubed. So there's 2 in common. So that's 5x squared is my GCF. What's that leave in the parentheses? Is it plus 3 or minus 3? Yeah, minus 3 because it's a negative. That's right, because we took both of the x's out. All right. This one. X squared plus 9x to the fifth. Is it in the right order? No.
Well, you gotta put your 9x.
9x to the fifth goes first. Then plus x squared. Now what? Nope.
1 is your.
All right, so there's a 1 in front of the x squared. All right, so 1 and 9, what's the only number they have in common? 1. All right, so, but how many x's do each term have in common? 2. You got x squared here, it's got 2 of them. And the other guy's got 5, so 2 of those can match up. So x squared is my GCF. What's that leave in the parentheses?
9.
Plus
Plus 1.
1. Because what times x squared gets me x squared back? 1. There's the factoring with the GCF for that problem. All right, let's get another one. 6x squared y plus 8xy plus 12y. Kind of hard to do descending order with this one because you got 2 letters, so don't worry about that. Let's just get the GCF. 2. I agree with that for the numbers. What about letters? Everybody has a y. So a y is part of your GCF. What's that leave in parentheses?
3x squared 4x
Good job. X cubed plus 6x squared plus 3x plus 18. All right.
in order.
That x cubed, x squared, plain x, plain number. That's in descending order. It's the right order. Is there a greatest common factor for all of those terms?
No.
3 goes into 6, 3, and 18, but it does not work for the x cubed. So it's not a GCF for the whole problem. So we can't use it. It's got to be for everybody. Okay? So no GCF for this one. So 1 technically, but it doesn't help us any to pull a 1 out. Right? Now, the next step in the rules of factoring, after you did GCF, was to look at it and count the terms. How many terms do we have here?
4.
4. Okay, so this is 4 terms. So this is where we're going to do grouping. I'm going to show you how to do that. Grouping is GCF twice. Okay? What you want to do with grouping, you've got it in the right order. Group the first 2 terms together. So I'm going to group these 2 together. X cubed plus 6x squared. And then I'm going to group the second 2 together. And I usually underline them. Okay. So on the set that's in parentheses.
You take the positive with the 3x?
Yes, with the 3x. Okay, that sign that's in the middle right there goes with this number. So whatever's here. That sign goes with it. Okay? Good question. I didn't think you'd say that. Now, let's look at this one as its own problem. What's the GCF of these 2? Be 1 for the number, and then we got x cubed and x squared. Be x squared, right? 1x squared. So the GCF of that first group is x squared. So I'm going to pull that out to the front. What's that going to leave in the parentheses just for the first group? Pay no attention to this other that's over here. We're not doing it yet. The second group that's underlined, we're not working on it yet. We're just working on this part.
X plus 6.
X plus 6 will be in the parentheses. X plus 6. Now, the next thing to look at is the underlined group. 3x plus 18. It's a positive 3x, positive 18. What's the GCF of the underlined group? 3. What kind of 3? Positive 3. This sign that's in the middle will always come straight down. Positive 3. What's left in the parentheses? X plus 6. Notice that these 2 little parentheses here are the same. That means things went right. Okay? Now, we're not done yet. That's GCF once. Now, what does this part have in common with this part?
X plus 6.
They both have x plus 6. What that means is the factors are x plus 6 and x squared plus 3. One factor is the matching one. The other factor is the stuff in front. X plus 6, that's the matching one. X squared plus 3, that's the stuff in front. That's the other one. Always going to work that way.
Matching first.
It doesn't matter. I tend to do that just out of habit, but it doesn't matter which one to do first. Okay. The GCFs that we pulled, yeah, the GCFs that we pulled out. Let's try this one. 4x to the third plus 2x squared minus 2x minus 1. Is it in the right order? Is there a GCF for the entire problem? No, that one on the end messes it up. Thought 2 was going to be it, but the one on the end messes it up. Okay? So, how many terms are there? 4 terms. So that tells me I'm going to use what method? Grouping. First 2 together. Second 2 together. What's the GCF of 4x cubed and 2x squared? 2x squared. What would that leave in their parentheses? 2x plus 1. I know this minus sign is going to come straight down and go in front of the GCF of the next 2. What's the GCF of 2x and 1? 1. That's right. If I pull a negative 1 out, which is what that's showing, that it's a minus 1, what's it do to the sign of both of those pieces? It makes it the opposite. So it makes it 2x plus 1. I pull out a negative. What times negative 1 gives me negative 2x? A positive 2x. What times negative 1 gets me a negative 1? A positive 1. Okay? Notice that the parentheses do what? They match. That means I did something right. Okay? My factors at the end, 2x plus 1, 2x squared minus 1. See if you can do that one by group. Use the previous 2 as a guide. All right. What's the GCF of the first group? 2x squared. Good. What's that leave in the parentheses? 5x minus 3. What do I pull out of the second group? That leaves the 5x minus 3, right? They match. That means I did it right. My factors at the end. 5x minus 3. 2x plus 5. Good job. 2x squared plus 5. Does take some practice. We're going to get some more practice as we go into the next type. Okay. X squared plus 7x plus 12. Okay. Is that in descending order?
Yes.
Is there a greatest common factor across the whole problem?
No.
No. Okay. How many terms are there?
3.
3. So that tells me I'm going to use what method? The X method. So I'm going to teach you how to do that. All right. When I was in high school, I learned guess and check, and that was basically you opened up 2 sets of parentheses and you guessed 6 and 2. Well, 6, and then you multiplied that back out the way we were doing in the first section, and see if it worked out to be 7x plus 12 on the end. It doesn't. So you had to start over. That was the horrible way of going about it. Okay, it was the way that I learned how to do it, and I got better at it because I had to. You didn't have a choice. Okay, what I want to teach you is a little better method that still involves guessing, but it's not so much full out check it completely and go from there. There's a little shorter method for checking it. All right. So what guess and check didn't do was give me a systematic approach to working this out. When I deal with a trinomial, something that's got 3 terms, it's generally in this form: ax squared plus bx plus c. I set up an x in the top window of the x. I'm going to put whatever a times c is, the front times the back. Okay? So for this problem, what's in front of x squared? 1. The back number is 12. So what's 1 times 12? 12. So that's the number that goes up there. In the bottom window of the x, so right down here, I'm going to put whatever b is. Okay? So for this problem, in the bottom window of the x, it's going to be the 7. Okay? What I want to do is fill in these 2 side windows. I need numbers that multiply to equal a times c and add to equal b. Okay. So for this problem, I need numbers that multiply to be 12 and add to be 7. Okay. So all I have to do is think about the numbers that multiply to be 12. So this is where knowing your multiplication tables comes in handy. Okay. So when I think about numbers that multiply to be 12, I think, okay, 1 times 12. But what's 1 plus 12?
13.
We know that's not right because it's got to add to be 7. Okay. What if I tried 2 times 6? That multiplies to be 12, but that adds to be 8. It's closer, but it's not right. What's the other option for multiplying to be 12? 3 times 4. What's 3 plus 4? 7. That's the right set of numbers. That's what we're finding with the X method, are those numbers. I know that 3 times 4 multiplies to be 12, and 3 plus 4 adds to be 7. Here's the beauty of that. We can take this trinomial, this thing with 3 terms, and we're going to turn it into something that has 4 terms so that we can use grouping again, because we already know how to do grouping. Okay? I'm going to replace the 7x with 3x plus 4x. I'm replacing the middle term with the two numbers that I got in the sides. Okay? And I'm putting an x on them because I need it to add to be 7x, right? 3x and 4x. It has to be 7x. Now I'm going to group that. First two together, second two together. Here's the great thing. You can't screw this up. It doesn't matter which one you put first. If I put 4x in the front, that's okay. And then 3x. It doesn't matter. At the end of it, it'll be the same. Okay? So it doesn't matter what order you put those in. Okay, so I'm going to group the first two together. What's the GCF of x squared and 3x? X, leaving x plus 3. What's the GCF of 4x plus 12? Plus 4. What do you know about those parentheses? They're matching up. I win. X plus 3 times x plus 4. That's the factored form of that. If I multiply this back out and simplify it, x times x, that's x squared. X times 4 is 4x. 3 times x is 3x. 3x plus 4x is 7x. That's from the original. 4 times 3 is 12. That's from the original. It works. Okay? Let's look at another one. Kind of get this idea going in our heads here. 4x squared minus 11x plus 6. I still go through the work of checking descending order and GCF. Don't ever forget those things. Those are important. Okay? 4x squared, 11x, and 6 don't have a GCF. It is in the right order. It has how many terms? 3. So that tells me I'm going to do the x method. What goes in the top of this x? 4 times 6, a times c, which is 24. What goes in the bottom? Not just an 11, a negative 11. That's important that you use that sign. Okay? So I need something that two numbers that multiply to be a positive 24 and add to be a negative 11. So we just need to think about numbers that multiply to be 24. Okay? 2 and 12. To multiply to be a positive 24, we have two options. We have positive 2 times positive 12 or negative 2 times negative 12. Which one of those will add to be negative? The positive ones or the negative ones? The only way things can add to be negative and multiply to be positive is if both of them are negative, right? So is negative 2 times negative 12, is that positive 24? Does it add to be negative 11? No, it adds to be negative 14. So that's not the right set. Good try. Let's try a different one. What else do we know that goes into 24 besides 2 and 12? 3 and 8. 3 times, both negative, so negative 3 times negative 8 is positive 24. What's negative 3 plus negative 8? Hey, that's the right pair. That's the ones we want to use. So we're using negative 8 and negative 3. Again, it doesn't matter what order you put them in the middle in. I'm going to put the negative 8 first because I think 4 and 8 are closely related, right? So that's why I'm going to put the 8x in the middle first. 4x squared minus 8x minus 3x plus 6. Now I can group them just like we did on the previous problems. What's the GCF of those two? 4x What's that leave in the parentheses?
X
X minus.
X. Yeah, X minus.
Yeah, good job. X minus 10. What do I pull out of the second pair?
3.
What kind of 3?
Positive.
What sign is right there in the middle?
It's a negative.
So it needs to be a negative 3.
Okay, then
Mm-hmm. Whatever sign is in the middle there should be in the middle on the next step. Always. What's that leave in the parentheses?
X plus 2.
X minus 2, because I pulled out a negative. What times negative 3 gives me positive 6? That's a negative 2. All right, now the factors are x minus 2 and 4x minus 3. Try another one.
Did you patent your answer?
No, I learned it from a different teacher while I was in graduate school. I went all the way through college doing it the old way, and then I got into grad school. And my teacher showed it to me. 6x squared minus 7x minus 5. What goes on the top of the x? So it should be negative 30. Yeah. And then on the bottom, negative 7. All right, so this one's a little different because you got a negative up top and a negative on the bottom. So we know that to multiply to be a negative, you got to have a positive and a negative. Okay, so let's think about things that multiply to be 30. 10 times 3 is 30. That's the first one I think of when I'm thinking about 30. And now, is it 10 times negative 3? That gets me negative 30, but that gets positive 7. So that doesn't work. I need negative 10 and positive 3 to get it to work right. So I get the right numbers, but I got to get the signs right as well. Now, it doesn't matter which one you put first. If you want to put the 3 first, that's fine. If you want to put the negative 10 first, that's fine. I'm going to put plus 3x first because I know 3 and 6. I know that GCF easily. What would the GCF of my first pair be? 3x. Leaving 2x plus 1. Second pair.
2.
Try again. What kind of 5 am I pulling out? A minus 5. So what times negative 5 gets me negative 5? A positive 1. So that changes those signs in the middle. Remember? Okay. That's it. I'll show you a few shortcuts as we go here. When there are some, I'm going to show them to you. When they're not, I can't show them to you if they don't exist. So I'm going to try to show you some as we get to some. So let's do this one. Let's do X method. Negative 14 up top, 5 on the bottom. Multiplies to be negative 14, adds to be 5. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. So not quite. Reverse the signs. Good. That's exactly what I wanted to hear. Try something. If it doesn't work, you're close. Swap the signs. Now, here's the shortcut that I can show you for this one. What's in front of x squared? 1. Anytime that there's a 1 in front of x squared, you can use this shortcut. One factor is x minus 2. The other factor is x plus 7. But that only works if there's a 1 in front of the x squared. If you did it the long way, and grouped it, it's going to get you the same answer. That's x plus 7, and then a negative 2, x plus 7. Wait, no, x minus 2, x plus 7. Same answer. That works when there's a 1 in front of x squared. If there's anything else there, you can't do that. You got to do the grouping method. There's not a shortcut to that. Okay? Say we had x squared minus 2x minus 48. Still got to do the x. What goes up top? Negative 48. On the bottom is a negative 2. So we still got to do the x the same way. That doesn't change anything. Multiply to be negative 48, add to be negative 2. Six, negative 8. Right? 6 times 8 is 48. You can get the signs. My factors, because there's a 1 in front of the x squared, would be what? Good job. X plus 6 because it's a positive 6. X minus 8 because it's a negative 8. Some nice shortcuts to that. Let's do another one. X squared plus 15x plus 36. $36 up top, 15 on the bottom. Multiplies to be 36 and adds to be 15. Somebody said it. 3 and 12, yeah. 3 times 12 is 36. 3 plus 12 is 15. What are my factors? X plus 12 and x plus 3. Both pluses because they're both positive. Okay. That shortcut only works if there's what in front of x squared? 1. It does not work any other time. Okay. All right. So far we've done GCF, we've done grouping, and then we've done the X method, which involved grouping sometimes. Sometimes we could get a shortcut and not have to group. The next thing to look at is when there are two terms. Okay, so we're going to look at those different scenarios. Okay, first scenario is going to be a difference of squares. And that would be something like this, x squared minus 4. It's in descending order. There's no GCF across the terms. There's only two terms to look at. It's got a minus sign in the middle and a squared on the x. That tells me that this is a difference of squares. This is the difference of squares. Difference in mathematics is what operation? Remember what that word means? Sum means to add. Difference means to subtract. Okay, so a difference of squares is a subtraction problem. Okay, so to be a difference of squares, you have to have a minus sign in the middle. Okay, what we want to do if we think it's a difference of squares is rewrite it as a difference of squares. So the first term is easy. What squared gets me x squared? X. Second one takes a little bit of thinking. What squared gets me 4? 2. If you can rewrite it like that, then it factors every time through a shortcut. X in the front, 2 in the back, plus, minus. Try another one, see if we can pick up this pattern. 16x squared minus 25. It's in descending order. Does 16 and 25 have anything in common? No. So we got two terms and a minus sign, so we're thinking difference of squares. What squared gets me 16x squared? 4x. What squared gets me 25? 5. My factors, 4x in the front, 5's in the back, 1's plus, 1's a minus. $25, x to the 4th, minus 144. Mm-hmm. 5x to the second squared minus 12 squared. What are my two factors then? 5x squared's in the front, 12's in the back. 1's a plus, 1's a minus. Bam. Differences of squares. It's a programmed pattern. Okay, you see it, you rewrite it, you get your factors. Okay, that's when there's two terms. Okay, now let's look at the other option when there's two terms. The other options when there's two terms is a sum or difference of cubes. Sums and differences of cubes is also a memorized pattern. Okay, so if we have two things that are cubed, a cubed plus b cubed, the way they factor, the sum of cubes is addition between them. They got a short piece and a long piece. Okay. The short piece going to be whatever's cubed here. So A, and whatever's cubed here, B is going to be A plus B on the sum. On the difference, it's A minus B. Okay. The short piece is the same. That's what you need to remember. The short piece always has the same sign. So on the pluses, it's pluses. On the minuses, it's minuses. Okay. The long piece, how many of these cubes, how many pieces did I use? I used one in the short piece, right? That means there's two left over. So that's A squared. And I used one of the B's. So that's B squared. That's the same for both of those. The middle piece is the opposite sign. I have no idea what letter I'm on. R. So if we had x cubed minus 8, I know it's not a difference of squares because that's a cubed. So I know it can't be something squared if it's a cubed, right? So the first piece is easy. That's x. What cubed or what to the third power gets me 8? 2. 2 times 2 times 2 is 8. So I know I'm going to have a short piece. I'm going to have a long piece. The short piece is x minus 2. The long piece, I'm going to have an x squared plus 2x plus 2 squared, which we know 2 squared is what? 4. So I really have x minus 2 times x squared plus 2x plus 4. It's a memorized thing. You're going to have to take the time to memorize it. Unless you want to learn long division of polynomials between now and next week, okay? Because that's the only other way to do it. Okay? Let's look at this one. 64 x to the third plus 27. This one's a sum. They're not going to get too big with the numbers here because cubic numbers get big fast. 2 to the third power is 8. 3 to the third power is 27. What to the third power is 64? So 4 times 4 is 16 times another 4 is 64. So it's 4x. Okay. Factors, short piece, 4x plus 3. Long piece, you're squaring 4x, multiplying 4x times 3 in the middle, and then squaring 3. What do you get when you square 4x? 16x squared, right? Minus 12x plus 9. This takes practice and memorizing that pattern. So memorize that pattern, you'll be okay. Just got to memorize that pattern. Like I said, they're not going to get big numbers. 125 might be, that's a big number. 10 to the third power is 1,000. So that gets big real fast. Okay. Let's do another one that's got other numbers in it. Let's say we had 125 x to the third plus 1. 1's a cubic number. That one's easy. 1. 5 times 5 is 25. 5 quarters, it's $1.25, so that's 125. So that's how I know that's 5x. Short piece, what's the short piece? 5x plus 1. Long piece. I got to square the 5x. What's 5x times 5x? 25x squared. The other end, I got to square 1. That's an easy one. 1 squared is 1. The middle piece is where most folks miss this. It's a minus sign, and then I'm multiplying 5x times 1. 5x. You can rewrite it as the sum of cubes like that, or difference of cubes. You're just learning this pattern. Oh, it's the same here. Square it here, multiply them together here, square it here. It's that same pattern over and over and over. You've got to just flat out got to memorize it. Okay. All right, let's put it together with everything that we've talked about, all the different methods. And we got to I'm just going to throw a problem to you, and we're going to talk about how to get to what method it needs to be done with. Okay? So let's start with this one. I told you this section is long. The next two are not nearly as tough as this one. This is the hardest section of the night, I promise you. Yeah, that's it. All right, let's do this one. 5x squared minus 20. Excuse me, thank you. All right. Let's go through the rules of factoring. First things first, is it in descending order?
Yes.
Good. Okay. What's the next thing we look for? Which would be 5. Everybody's got a 5 in common. Pull that out. What's left? Not just x minus 4, but x squared minus 4. Okay. Now, once you've done that, we were kind of learning our way through factoring. We were done after that. Well, we've got to keep looking at it. Will x squared minus 4 factor any further? And if so, how? So x squared minus 4 is a difference of squares, right? So it's x squared minus 2 squared. So yes, we can break that down as what two factors? X is in the front, 2's in the back, 1's plus, 1's minus. There is the factored form of that original problem. But the blue version causes problems when we go to solve these later on. Okay, so we got to get it factored all the way so that we can use it to solve. 10x to the second minus 80x plus 160. It's in order. Good. GCF of 10. Good, Sam. So 10. What's left in the parentheses? Minus 8x. Good job. 16. GCF of 10. 160. That'll make a difference. All right, now, will that x squared minus 8x plus 16, will it factor any further? And if so, what method? It's got to be the x method because there's 3 terms, right? What number goes up top? 16. Negative 8 at the bottom. Multiply to be positive 16, add to be negative 8. Negative 4 and negative 4. Can I use my shortcut? Why can I use my shortcut? That's right. Because the x squared right here, this it has a 1 in front of it. So that means my factors are x minus 4 and x minus 4. I would accept that. What's another way I could write that? There's another way you could write that. Put it squared. X minus 4 squared. I would take the longer version of that. That's fine with me. But understand that that's the same thing. Okay. All right. So pretty good. We've done GCF and difference of squares. You did GCF and X method. That's great. You're doing good. You guys, you may not feel like you're doing good, but you are. Yeah, all week long until and get study up for the test. X to the third minus 5x squared minus 4x plus 20. Let's take ourselves through the rules of factoring. Is it in order?
Yes.
Mm-hmm. Is there GCF across the board with all 4 terms? No. But because there are 4 terms, we're going to do grouping. Okay? So first 2 together, what do they have in common? X to the second or x squared. What's that leave in parentheses? Okay. What do the next 2 have in common?
4.
Kind of 4.
-4.
A minus 4. What's that leave in the parentheses? Minus 5. What times negative 4 gives me positive 20? That'll be a negative 5. I always got to change the sign. All right, so our factors then are x minus 5 and x squared minus 4. Will either of those factor further? That x squared minus 4. We've seen that already tonight, right? I'll tell you, part of being good at factoring, experience. What makes a person a really good guitar player? Experience. Very few people in this world have ever picked one up and just magically been able to go, this craziness. Crazy good straight off the bat. They've always had experience. Experience with factoring. More you've seen, more likely that is to come up again. Okay, so the practice is important. So what does x squared minus 4? It's x squared minus 2 squared. So that's x plus 2, x minus 2. And then we still got the x minus 5 that we started with. There is the factored form for that one. There we've employed all of the rules of factoring. Mix that in. Deep breath. All right. Let's go to the last couple of sections here. Okay. So let's talk about square roots next. The section R.7, square roots. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 examples of square roots. And then one more section. Okay. All right. Our idea here is to simplify square roots, not just punch them in the calculator. Yeah, go ahead. I'm still going to be teaching, so I'm not going to stop. So if you need to go, go. All right. Simplifying square roots is not getting a decimal approximation for it. It's actually working it out. Okay. So let's take a square root that we know already. Square root of 9. Everybody knows the square root of 9 is what? 3. Everybody knows that. But why? Let's think about the factor tree for 9. 3 and 3. There is a pair of 3s. If we're taking a square root, we're talking about pairs. Pairs of 3s. There is one pair of 3s. So that's why the square root of 9 is 3. If we talk about the square root of 16, what's the square root of 16? Everybody knows it's 4. But if we did the factor tree for 16, that's 8 times 2, 4 times 2, 2 times 2. There's 2 pairs of 2s. That's where the 4 is coming from. When we're simplifying square roots, we're looking for pairs. Okay? And the factor tree method is my way of doing it. Some people have you memorize all the square numbers and then divide. I'd just rather just be able to do a factor tree and count pairs. You could, but that's not a complete factor tree. Factor trees aren't over until they get to prime numbers. Okay? But you may need, when we do a different number, you may need the prime sets of 2s. That's why we don't do 4 and 4 as a pair. It works for 16, but it may not work for 48. May not work for 127, something like that. Okay? So that's why I don't do it that way. All right, let's look at one that's a little different. That actually is simplifying a square root. So square root of 18. Square root of 18 is not a pretty number. If we punch that into our calculator, second square root of 18, it gives us this decimal for that. We don't want the decimal equivalent for that. We want the exact solution. Okay? So we want to simplify the square root of 18. The way to simplify the square root of 18 is to make a factor tree for 18. So all we got to know is one way to multiply to be 18. It doesn't matter if it includes a square number or not. So what's the first way you think of to multiply to be 18? 2 times 9, 6 times 3, doesn't matter. Okay? All right, that's fine. It doesn't matter as long as those two numbers will multiply to be 18. Doesn't matter what I start with. 2 times 9 works. 9's not a prime number, so I'm going to break it down further. 3 and 3. Now, at the end of each branch is a prime number. I look for pairs. There's a pair of 3s. So that means there's a 3 on the outside. This 2 stays on the inside. When I was growing up, I had 2 brothers. We lived out in the country, so we got to run around a lot and not have a whole lot of supervision and things. But one of Mom's rules was, if you're going to go off far, you got to have a buddy. Okay? And if your buddy won't go out gallivanting through the woods with you, you got to stay in. Okay? So that's the way I kind of preach this. Got a pair here. There's 2 of you, so you can go out. You can go outside the radical. If you don't have a buddy, like this 2 didn't have a buddy, he had to stay in the house. But have a buddy to go out. So you got to have a little set to go outside. Okay? That's the way you want to think about that. Now, on the calculator, if I hit 3 and then radical 2, I'll show you that that's exactly the same number. Okay, it's the same decimal equivalent. What we found is the exact solution that's simplified all the way. Okay, and that's one of the things we're going to have to do in a couple of weeks when we start solving these things, is using some square roots to do that. So we want to get the exact solution, not a decimal approximation. Okay, let's look at another number. Let's get square root of 24. 24's got a lot of different ways to multiply to be 24. What's the first one somebody thinks of? 6 and 4. 6 is a composite number. It needs to break down. 3 and 2. 4 is a composite number. It breaks down. 2 and 2. I've got a pair of 2's. And then I have a 2 that doesn't have a buddy and a 3 that doesn't have a buddy. Okay? So there's 1 2 that's going to come to the outside. The 3 and the 2 that don't have buddies go back on the inside, and they multiply back together to give us 2 radical 6, or 2 square root of 6. Say we had the square root of 108. We'll try to break that down. What do we know about 108? This is where knowing your multiplication tables kind of helps too. I know 108 is 9 times 12. Or better yet, maybe you don't know that. Maybe you just know that it's even. How many times does 2 go into 108? 54 times. That works too. And then you can break that down. 2 is a prime number, so we're done with that one. 54, we know something about 54. It's even. 2 goes into it. How many times? 27 times. And I do know something about 27. We're getting to numbers that I know a lot about now, right? 3 and 9. And then 9 breaks down to 3 and 3. So for this one, I got a pair of 3s, a pair of 2s, and then that 3 right there doesn't have a buddy. So he's got to go back on the inside. So on the outside, I've got a 2, a 3, and then I've got a 3 on the inside. Final answer would be 6 square root of 3. The way to know if you did that right is check it. On your calculator, type in square root of 108. And then type in 6 square root of 3. If it doesn't give you the same decimal back, you did it wrong. Something's wrong. Okay? So be careful of that. So a negative and then 300. So a negative on the outside of the square root and then the number 300. Does that negative on the outside change how we do anything? Absolutely not. Okay? So we're just going to break down the 300. 103, right? That's the easiest way. 3 times 100. And then 100, 5 and 20. 20, 5 and 4. 4 is 2 and 2. So I have a pair of 5s, a pair of 2s, and then a 3 that's left on the inside. So that negative is still there. 2 times 5 on the outside. So that ends up being negative 10 radical 3, or square root of 3. Five times 2, 1 for each pair. The negative that was already out there is just, it's like a negative 1. It's out there in front. Excuse me. Okay. negative square root of 300. And then negative 10 square root, what was it, 3? Same number.
What if that?
All right, what are you typing in? Multiply that together and then square root of 3.
This lady?
Negative, yeah. Type in negative 300. And it'll give you that same, that's the exact same number. You got the right number there.
Oh.
All right. Let's do a fraction. Square root of 16 over 25. Good news is we do good numbers when we're dealing with fractions. What's square root of 16? 4. What's the square root of 25? Do 144 over 49. Yep. All right, now let's multiply some square roots together. 2 more examples in this section, and then we get to the last section, okay? Radical 6 or square root of 6 times square root of 12. The way this works with square roots and multiplying, it's outside times outside, inside times inside, okay? So on this one, do we have anything on the outside? No. There's ones, but 1 times 1 is still going to be 1, right? So I'm just going to multiply 6 times 12 on the inside. And that's going to be 72, right? Then I'm going to simplify. I got it from 6 times 12, so I'll just use it. 3 and 2, 3 and 4, 2 and 2. So a pair of 2s, a pair of 3s. So that's 2 times 3, radical 2. 6 square root of 2. Outside times outside, inside times inside, and then simplify. We had 3 square root of 8 times negative 5 square root of 12. Outside times outside, inside times inside. Outside times outside, inside times inside. 3 times negative 5, negative 15. 8 times 12. Try again. Close. 96. All right. Which one of those am I going to break down? The 96 or the 15? The 96, because it's on the inside of the square root, right? So I break it down. I got it from 8 times 12, so that's what I'm going to use. 4 and 2, 2 and 2. 12 is 2 and 6. I have 1, 2 pairs of 2s. And then this 3 and this 2 here don't have buddies, so they got to stay on the inside. I have the negative 15 that was out there to begin with. I have a 2 and a 2. And then I have a 2 and a 3 on the inside. So that's negative 30 times 2 is negative 60. Radical 6. Multiplying square roots. Outside times outside. Inside times inside. And then simplify. using the factor tree stuff. Okay. All right. That is section R7, or what we're doing out of it today. Let's get the last section. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 examples between us and going home. Surely we're out of here by 8 o'clock. All right. Maybe my voice will last. It's getting hard. Complex. Yes. All right. Complex numbers is what we're going to be dealing with. A complex number is started out by taking the square root of a negative number. Okay? Square root of -1 we're defining as lowercase I. Okay? When you see lowercase I, it's coming from a negative underneath the radical or underneath the square root. Okay? If we were to square I, we would get -1. If we were to take I to the third power, we'd get -I. And then if we take I to the fourth power, we'd get +1. That little chart right there is important. It'll come into play later on when we start multiplying complex numbers together. Later on, I mean by examples 7, 8, 9. What I mean. Okay. So that's going to be used to help us simplify. Any power higher than I to the fourth, it starts repeating. So I to the fifth is the same thing as I. I to the sixth is I squared. I to the seventh is I to the third. I to the eighth. It just repeats over and over and over. That cycle through. Okay? So that's how we'll use it. We generally don't have to do too much with anything bigger than I to the fourth in Math 100 or 110. Okay? So that chart, know it. Okay? A complex number is A plus BI. This is called the real part. This is the imaginary part. Now, that imaginary idea is a really unfortunate naming incident in mathematical history. There were these two guys that were pen pals back in the day. They were mathematicians, and there wasn't Twitter and all this, Snapchat. They couldn't Snapchat each other their math problems, so they got into a contest with one another. They were both like leading in their field and teachers, and they got into a contest with one another of solving problems. And one would send a problem to him, he would work it out and get his solution, and then he would send that answer back, and then send the other guy another problem and say, challenge accepted, here you go, see if you can do this one. Well, what they got to noticing as they kept challenging each other back and forth is that when they found the answers to some of these problems, they knew that there should be a certain number of answers, but they didn't have the mathematical tools to be able to find them. Okay? And they kept saying, okay, well, I know that there should be 4 answers to this particular problem. I found 2 of them. There should be 2 more, but I can't find them with the tools that we know how to use. There were some things that hadn't been invented in mathematics yet. This is a long, long time ago. So they started saying there are 2 real answers and then 2 imaginary answers because they couldn't find them. They knew they had to be there, but they couldn't find them. So they called them imaginary answers. The name stuck. That's not a good name for them because they exist, but they just continued to call them imaginary for tradition's sake. It's kind of like at church. You always do the offering on the second hymn because that's what your church has always done. There's no real reason for it. You ask somebody why we do that. Well, that's what they did when I started coming here. My granddaddy did it that way. That sort of thing. There's no real reason for it, but That's what they've always done. It's kind of the same way with imaginary numbers. When you see imaginary, it doesn't mean imaginary as in like unicorns and that sort of stuff. I'm sorry if I killed your dreams. Unicorns do not exist. Sorry. Imaginary is just an unfortunate naming accident in mathematics. Okay, so where does this tie into R7? Because this seems to be out of place from what we've done already. It ties into R7 when we look at problems like this, where there's a negative on the inside of the square root. Let's take a problem like we've already done before and put the negative in there. So a square root of negative 24. Okay. As far as simplifying that square root, we're going to do everything with the factor tree the exact same way. Okay. So factor tree on 24, you use 8 and 3. It doesn't matter what you start with as long as it multiplies to be 24. You get a pair of 2s. There's 2 on the outside. Because there's a negative, there's an I that comes out to the outside. And on the inside, we got 3 times 2. So that's 2I square root of 6. The I, that I is because of that negative. That's the only reason that I exists there. Because it was a negative underneath the square root. Negative on the outside of the square root doesn't do anything. Negative on the inside puts that I out there. Square root of negative 72. We know automatically there's going to be an I at the front because it's a negative underneath there. We could start with that and then break down the 72 using whatever numbers we want. As long as they multiply to be 72. 6 and 12, that's a good set. 3 and 2. 2 and 4, or 2 and 6, and then, or 4 and 3, doesn't matter. And then 3 and 2. So I've got pair of 2s, pair of 3s. That's going to be what on the outside? 6, and then a 2 on the inside. 6I square root of 2. What about the square root of negative 35? Well, 35 breaks down as what? 7 and 5. But 7 and 5, do they break down any further? No. So are there any pairs? No. So how does this simplify? What can come out? An I, because it's a negative 35. And you just put 7 times 5 back together in the middle, inside, to be 35. So that can simplify a little bit because the negative in there, that negative, that's where that I comes from. So a negative underneath the square root gets you the I coming out. Okay. All right, tying that back together with the multiplying idea. When you're go ahead.
You just put that I there.
Because there's not a pair, you can't do anything. You can't pull anything else out. All right. Now, when you got the multiplication thing happening, it is important that you simplify the negatives on the inside of the radicals first. Okay? These become I radical 7 times I square root of 7, right? It's important that you do that because if you don't, then when you multiply it, you lose that complex part. Okay? What's I times I? I squared, right? What's the square root of 7 times the square root of 7? Square root of 49, right? What's the square root of 49? 7. So we have 7I squared. What do we know from the beginning of this section I squared really is in our chart? -1. Okay? So we're going to replace I squared with -1. So we have 7 times -1, which really is -7. Okay? Joe, you may have been, maybe, were you out during that chart? Okay. Get that chart written down. That's going to be important. Okay. Yeah. All right. Let's.
I did that in your whole 18 minutes Snapchat.
Oh yeah. My story.
Yeah.
Yeah. I like stories.
Yeah, they don't mean I'm so lost.
Okay. So you're not lost, or you are?
I got lost like that metal. That's still in that route.
You're lost as a last year's Easter egg in tall grass. All right. Let's look at another one of those then. Square root of -12 times the square root of -15. Okay. Again, anytime there's negative under the square root, we've got to simplify that first. So pull the eyes out. So poke their eyes out first. I radical 12, I radical 15. All right. When you multiply those two together, you get I squared, and then whatever 12 times 15 is. How much? 180? 180. Good deal. All right. Then we break, break down the 180. 18 and 10. 6 and 3. 2 and 3. 5 and 2. So we got a pair of 3s and a pair of 2s. And we got this 5 that doesn't have a buddy. What's on the outside? Three times 2 is 6. I squared, square root of 5. Okay. What do we know I squared really is? -1. What's 6 times -1? -6, right? So that's -6 square root of 5. That's the final answer for that. Anytime you see I squared, it changes into a -1. Okay. Be important. All right. Let's add and subtract some complex numbers. Okay. And subtract complex numbers. All right. 3 plus 5i, that's first complex number, plus 6 minus 2i. That's a second complex number. This is no different than adding and subtracting things with x's. Okay? Like terms go together. What's the like term that goes with 3? The 6, because it's a plain number, right? What's 3 plus 6? 3 plus 6? 9. What's 5i plus -2i? You've added complex numbers. Okay. I want to show you a nice little trick with your calculator. As I've told you, I'd be honest with you about shortcuts. Here's a shortcut. I don't know if it's a shortcut or not, because adding and subtracting is pretty easy. Parentheses 3 plus 5. To get the I for your calculator to do this addition for you, you're going to hit second and then the decimal point. And it'll put an I right there. close those parentheses, plus parentheses, remember what our other number was, 6 minus 2i. So with the calculator, I'm going to hit 6 minus 2 second decimal point to get the I. Hit enter. Boom. It adds those together for us. That's beautiful. I don't know that it's worth it for addition and subtraction. Maybe it is. Okay. It takes me longer to type it in than it does to do it for addition and subtraction. But let's do a subtraction problem. 3 plus 5i minus 6 minus 2i. Now, if I did that without the calculator, it's still like terms. 3 minus 6, negative 3. 5i minus negative 2i, positive 7i. Now, if I'm not sure of myself, I can go right to my calculator and I can type that in. 3 plus 5i minus parentheses 6 minus 2i. I did it right. Okay. Your calculator can handle the i's. I don't use it much for addition or subtraction just because I'm faster at just doing it. Because it's just like terms. It's not difficult. That doesn't mean you can't. Okay. Now, when it comes to multiplication and division, maybe it is a little more helpful with that. Because multiplying and dividing, you got a lot of stuff going on. So let's look at a problem of multiplying. 3 plus 5i times 6 minus 2i. I'm being creative with my examples. This is multiplying. Okay? This is just like what we did at the beginning of tonight, at lecture tonight. It's just multiplying with distributive property. If you were going to do this by hand, I'm going to take you through doing it by hand, and I'm going to show you with the calculator. Okay? If you're doing it by hand, it's 3 times 6. 3 times negative 2i. That'd be negative 6i. And then it's 5i times 6 would be plus 30i. And then 5i times negative 2i would be negative 10i squared. We're smart. We know that I squared really turns into what? Not 1. Negative 1. So that I squared is really negative 10 times negative 1. Makes it plus 10, right? Now I'm going to put my like terms together. I got an 18 and I got a positive 10. That's 28. And then negative 6i plus positive 30i would be positive 24i. That's beautiful. Probably not quite as pretty as doing it this way. 3 plus 5i parentheses 6 minus 2i. Without having to do all that converting with I squared and all that. That's much quicker for multiplication. So I think it's advantageous to do it with the calculator for multiplication. Definitely. Okay. Let's do a division problem. 3 plus 5i divided by 6 minus 2i. If you had to do this by hand, you would have to multiply the top and bottom by 6 plus 2i. What that's called is a conjugate. And when you multiply all that out, you get like 18 plus 6i plus 30i plus 10i squared on top. On the bottom, you get 36 plus 12i minus 12i minus 4i squared. And then you got to simplify all that mess And so you get 18 minus 10 would be 8 plus 36i. And on the bottom, you get 36 plus 4 be 40. And then you can simplify that a little bit further and get 8 over 40 is 1/5. 36 over 40 would be 9 over. That's better than that. 4 goes into 36 9 times. 4 goes into 40 10 times. There you go. That's what you end up with. I wonder if I get the same thing if I just do this in the calculator. Parentheses 3 plus 5i divided by parentheses 6 minus 2i. I'm going to hit math, enter, enter. I get the same answer. I probably would never do a complex number multiplication or division by hand if I'm to turn it back to fractions. Yeah, because it gave me the decimal here, and I hit math and enter twice to turn it into a fraction. That's all I'm doing. Make sure the key to doing it with the calculator though is the parentheses. You don't put the parentheses around it; it's going to mess it up. Okay, so be very careful of that on these problems. Be very careful of that. All right. Suggested problems. On the first section, 1 through 37. Odd. What was that? First section was R3. R4. Yeah, this is just practice problems out of the book. Was 45. We didn't do all of R4 at all. We'll come back and get some more of it later. And then R7, 1 through 45, 51 through 69. Odds on all those. These are just practice problems. You don't have to do any of these. 1.3. And I'm not putting page numbers because the different for the new different versions of it. But that problem set should be pretty close to the same out of all those sections. Okay. You'll have a Canvas quiz come up either tonight or tomorrow. That'll be due by next Monday. Next Monday we will have labs. If you miss those, remember you can't make those up. They're zeros. Okay, so don't miss the labs. And then your test, we're not going to take it in class next week. I'm going to make it online. Okay. IE means it'll be open note when you take it. Okay. It's a chance to help. I'm not sure about that yet. Nah. Well. Yeah. So would your notes. But anyway, so that's the plan of attack. So you guys enjoy your week and email me if you got questions, concerns, and we'll go at it again next week. Labs at normal time, okay? Our normal meeting time. We'll do labs, okay?